I am here today, I'm delighted to be here today with Dr. Ernest Rutter, BSc, ARSM, DIC, PhD, CGO, elected Fellow of the American Geophysical Union. I'm delighted to be here. Dr. Ernest Rutter, thank you so much for agreeing to the interview. You're a geologist and you've worked in the field of fracking for some years, as well as lots of other fields. Can you explain to our viewers who may not know what a geologist is and indeed what a geologist does, what it is, and also about your experience, your professional experience and academic experience in terms of fracking in particular?
A geologist does all kinds of different things. There are different kinds of specialities. There are those who work with fossils. There are those who map sediments and sedimentary basins. There are those who look at processes which take place inside mountains and the way in which rocks get deformed in the course of mountain building. And I'm in that latter category.
Okay.
So my speciality area in geology is the deformation of rocks, how they fracture and flow and get carried about. As part and parcel of that, it's important to understand how rocks respond to pressure, temperature, fluids, stress, the rate at which they get deformed, all of those things. And these are things that we can study in the laboratory by means of high pressure, high temperature experiments. And I've spent most of my career doing that kind of work and also measuring the physical properties of rocks, for example, how quickly acoustic waves, seismic waves pass through them, how that depends on pressure and temperature and the kinds of fluids that might be present in them, and how quickly fluids, particularly gases and liquids, will flow through the pore spaces in rocks. So that's called petrophysics, rock physics. So I range from structural geology through experimental rock mechanics to petrophysics. That's my area of speciality.
So you said earlier to me, a jack of all trades, a master of all.
Well, one tries to be because the Earth is such a fascinating place, and you can never get bored studying rocks. There's a famous early geologist called James Hutton who encouraged all men to read the Bible and study geology.
Really?
Yes.
Wonderful.
They're
Will you
the two
never
most
get
important
bored?
things you can do. You can't get bored, it's not possible.
No. So your desert island disc special things would be the Bible and some special geology books?
Well,
Actually, on a desert island, you can have a look
around and it's all there.
Absolutely.
So every holiday is a busman's holiday.
Lord Chris Smith put you on his panel a few years ago to look into shale gas exploration, fracking. Was that in the UK?
That was worldwide because we took evidence from experiences in other countries, particularly the United States.
Right. Okay. Fantastic. And what has been your personal and professional experience in terms of shale gas exploration with companies and things like that? Or has it always been advising the government? And
No, I first of all became involved in shales as rocks, not really having known much about them before, about 10 years ago. And that was because after the early boreholes were drilled by Quadrilla in Lancashire to explore for shale gas, some small earth tremors were induced.
right.
And of course it was very important to try to find out why this was happening.
Okay.
And because I'm interested in faults and friction and the way they lead to the production of earth tremors, I was asked to have a look at some of the rock samples that they'd recovered from the boreholes with a view to interpreting what could be interpreted from those samples, which might indicate how one might minimise the hazard of induced seismicity, induced earth tremors.
Do you think that in the UK that fracking could work here like it does in the US?
Potentially, yes.
Okay.
But the key thing, as with any kind of new mineral development, you have to look at what is there. You have to drill holes. You have to explore. You have to assess the size of the resource that you have, and you can only do that by drilling holes. You can get a certain amount of information by remote sensing methods, geophysical methods, but at the end of the day you need to drill holes. The problem in this country is that we haven't drilled many holes, so that the basis for making informed conclusions, drawing meaningful deductions is not very strong. And
at the moment.
That's still where we are because of the moratorium that we've recently had.
So would it be fair to say that you would be very much in favour of more exploration and just more investigations to see what's going on?
Without any prejudice as to what kind of conclusions might be drawn.
Okay.
You explore, you interpret, you draw conclusions, and then you decide what you're going to do. Because at the end of the day, there are people who are putting an awful lot of money into this activity,
absolutely,
and they've not made a penny out of it yet. And the people who are carrying out the exploration are not going to make any wrong decisions if they feel that it's not going to work as a result of, say, drilling 50 or 60 exploration holes. Then they'll pull out.
What would you say to Rishi Sunak right now, if you were advising him right now on fracking? What would you say to him? Because during the hustings for the Conservative leadership contest, he was very pro-fracking. In fact, you know, some would say he did as well as he did, even though he didn't win, although he has ultimately won by, well, what I think was a coup. You know, but by saying that he supported fracking if the local authorities and local people were in agreement. But as soon as he got in, he overturned Liz Truss's, permissions for fracking. So what would your advice to him be?
Well, there was a reason for that, and that is that the government commissioned the British Geological Survey.
I was about to ask you about that, yeah.
To investigate how things had moved on since the moratorium had been in place.
Yeah.
Have we made any progress towards being able to predict the size and likely frequency of occurrence of tremors? And the answer to that is a lot of work has been done, but it's an incredibly difficult problem.
So they were on the fence, weren't they? It was neither here nor there, was my understanding.
So at the present time, the Geological Survey, in all honesty, really couldn't say we can definitely predict every possible tremor that's going to occur and how big it's going to be. And then the politicians had to make a decision based upon that report.
It does seem ludicrous, doesn't it, that we are importing our gas and wood chips, obviously Drax is not too far away from here, from America, across the Atlantic Ocean in ships, you know, that powered by diesel. Obviously the CO2 emissions, if one believes that CO2 is, you know, causing climate change, even if you do believe in that, surely it must seem ludicrous.
Absolutely, absolutely. But what we have is what we have. If we get to a situation where we can say with a lot more confidence about what the frequency of earth tremors is going to be, and if the traffic light system is revised to more sensible levels.
I was going to talk to you about that.
Then yes, I think that every effort should be put into trying to develop a UK shale gas industry, again without prejudice. You can't press ahead with something if it's not going to work, and we just don't know the answer to that yet.
So more exploration.
Absolutely.
And in a way,
someone's got to pay for that. Someone's got to take risks with real money.
Well, I mean, we do have obviously Quadrilla, and we have I can't remember the other, Ineos.
iGas.
Yeah.
And Ineos.
Yeah.
And there are a number of other ones as well in different parts of the country.
They're willing to put the money in, but of course the government needs to be on side. I mean, fracking used to be extremely unpopular. There was a huge amount of money ploughed in, we don't know where from, to anti-fracking, protests and misinformation or just information that they couldn't be sure of at the time, as you say, because the exploration hasn't necessarily been done yet. So Ed Davey, when he did the traffic light system, he made it so ridiculously low, didn't he, in terms of seismic events?
Lowest in the world. Lower
than somebody digging up the road or the HS2 or even quarry development.
I mean, well, the the shale gas industry was incredibly tightly regulated, far more than any other kind of comparable
So
industry.
that was prejudice. There was prejudice there in a way.
It was felt that there was a need to demonstrate that we had a tough regulatory scheme, and
Right,
we do.
okay.
But you compare that with, for example, geothermal energy that's being developed in Cornwall in the United Downs project. There is no comparable regulations, and it involves injecting fluids into the ground.
Really?
And they do produce earth tremors. It's been reported in the news, and
Yeah.
yet people are quite happy to accept geothermal energy, nice clean energy, generating earth tremors, but not dirty shale gas.
Yeah, and as we've just discussed, we still need the gas, so it's just coming across the ocean and producing more CO2 emissions.
Yes, well, I believe that number one priority is national security, and that includes energy security.
We agree completely
We have
on that.
to give number one priority to that. The second priority is people's immediate needs.
Yes.
And we're seeing that being enacted right in front of us at the present time with inflation and the high price of energy across Europe, because we can't fix the prices ourselves in the UK.
And of course we couldn't we, with the cost plus system, if we were getting our own gas out of the ground, the Crown owns it. We could decide how we sold it.
But the distribution of gas takes place in pipelines that are connected to Europe, and the whole pricing structure for energy in the home and in industry in Europe is set at Europe-wide level. And that's why people say shale gas won't do anything to the price of energy, and it won't, because of the way in which the...
But could that not be changed, as we're not in Europe now?
No, we're still there. We're still there. We're connected with pipes, and the prices are still set on a Europe-wide basis. But what would happen would be that there would be increased security of supply. And security of supply, as I indicated, is a top priority, and it's much better to produce our own homegrown energy than to import it from anywhere.
No, I totally agree with you on that, although I have spoken to other people in the industry that said that there could be ways round the whole cost and pricing thing, but that's obviously a different issue. Could you talk to me a little bit about what fracking is and how it works, and the process, including the timelines in terms of how long it takes to drill the well, how long the actual water going into the ground takes, and the potential tremors and things like that, please?
Well, what we're talking about is the production of shale gas, that is to say, gas which is contained within the rock that we call shale.
Okay.
Now, just let's step back to how gas comes out of the ground.
Okay.
How we get at it. Conventional oil and gas reserves, just talking about gas for the moment, are made of three parts. They're made of a source rock, which is very often a shale,
Okay.
a place which a rock which contains a certain proportion of organic matter that was laid down together with the mineral components of the rock, and it was buried and compacted, and temperature went up, and that caused gas effectively to be driven off the organic components, but it stayed trapped in the rock. And then we have to have a reservoir rock so that what gas does manage to get out can accumulate in a very porous rock like a sandstone, which might be 25% open space.
Right.
That's a conventional reservoir. And then you have to have something to stop that gas from escaping upwards.
Okay.
And that's a cap rock over the top.
Right.
And that might be another shale. It might be rock salt or something like that. Three components to a conventional reservoir system. A shale gas reservoir is called an unconventional reservoir because the shale is the source rock, it is the reservoir rock, and it is the seal all in one.
Right.
It's a complete petroleum system. Now, when you think about, or a complete gas system, when you think about how old some of these rocks are, and most...
How old are they?
Most shale gases are typically Jurassic or Carboniferous in age, so that's something on the order of little under 200 million years, or almost twice that old. these rocks have been sitting around, buried at depths of several kilometres, and gas has been produced, and gas has stayed trapped in the rocks. It's very hard to get gas out of a low porosity rock like a shale. It just stays there underground, it doesn't go. So if we're going to exploit the gas which is trapped in shale, in the source rock, which hasn't migrated into a more easily accessible reservoir rock, we have to resort to rather more heroic measures in order to persuade Mother Nature to give it up.
Okay.
And this is where the hydraulic fracturing comes in.
Okay.
The misnomer is fracking. Hydraulic
Right.
fracture is what it
Okay.
is. And this is a technique which has been used for stimulating oil and gas wells and water wells since 1947 when it was first deployed.
So it's not new.
No.
Talked
And
about as if
since
it's a
that
new
time,
process.
around 7 million fracking operations have been carried out worldwide.
Right.
And the probability of any one of those going wrong is extremely small. You can count them on the fingers of one hand almost.
Okay.
So it is a proven, relatively safe way of exploiting gas. But like all engineering operations, you have to be careful.
Yes.
And there's always a little bit of risk involved, always, in everything we do.
There's risk in crossing the road, isn't there?
It's been observed that a person who makes no mistakes usually doesn't make anything.
I'm going to use that. I like that.
That is very, very true.
Yeah.
So with proper engineering practice, one should be able to extract the gas from shale. Now, to do this, we have to recognise that the shale deposits that we're talking about are very extensive, thin layers. They may be just tens of metres thick, but there may be many square kilometres in lateral extent. So it's a thin, flat slab. So we have to mine gas out of a thin, flat slab. To do that, you have to drill into the slab, and because
How
of the
big
shape
is
of
the
the
hole?
thing,
Sorry to interrupt, but how big is the hole, just for our viewers?
oh, the hole itself is
Not very big.
10 centimetres, 15
Okay.
centimetres. It's bigger at the top, but you have to make the hole get smaller and smaller and smaller as you go down.
Like a funnel?
Because the stuff at the top, they've got to take the weight of everything that lies
Right,
beneath.
okay.
So the diameters have to decrease. But right at the bottom, it's just a few centimetres.
Okay.
So we don't want the drill to go straight through this thin layer and come out the other side. Otherwise, you'll miss it if you blink.
Right, okay.
So what you have to do is to deflect the drill horizontally, so it runs along the layer instead of across it. This was the first really important technological advance which was made in the 1980s.
Okay.
Directed drilling.
Right.
Being able to steer a drill. Now just imagine a string of spaghetti,
Okay.
200 feet long. It's very wobbly,
Yeah.
and that is the drill string. You're going to
Right.
drill that drill string down, and you're going to make it steer itself horizontally down by about 3 or 4 kilometres and horizontally by 3 or 4 kilometres. The technological challenge in doing that is just phenomenal.
Yeah. Amazing.
It's in the same league as the space exploration activity.
Absolutely.
How to steer a drill, to steer it at that depth.
So is it computerised, obviously?
It is.
Yeah.
And it uses sound waves and
Right.
magnetic fields to do the steering, and
It's
gyroscopes, all sorts
extraordinary.
of things. And also a drilling head which can be bent. So it's like a worm. It can be sent in different directions, up and down, sideways.
So the
And
anti-fracking people quite often talk about it as if it's a very crude process, don't
not.
they, as part of their propaganda?
Really
But it
high-tech.
really isn't at
Yeah.
all. Yeah.
And that's why it's so
interesting.
expensive, of course.
Yeah.
So now we've got our drill going horizontally,
Yeah.
but the deposit may be kilometres that way and kilometres that way.
So, okay.
What we want to do then is to drill two holes down, and then go horizontally in opposite directions. But then we want to go down and off to one side, and then down, and then go horizontally. So that we end up with a series of horizontal bore holes which completely cover the whole deposit.
Right.
So once you have generated a set of holes, horizontal holes, parallel holes in a bed of shale, you then have to persuade the the shale bed to give up its gas, because it won't just flow spontaneously into those boreholes. And that is where the hydraulic fracturing comes in. And what has to be done is to, if we've got a series of holes like this, is to generate a series of cracks about 20 meters apart. So there might be about 30 of those fractures induced on one borehole, and you might have 50 boreholes. So you've got to induce a lot of cracks. It doesn't take very long, just a few hours to do each one. And the way that is done is, this is a really clever technology.
Okay.
You start from the furthest end of each hole, and you have an inflatable packer, which like a balloon in the borehole. So you isolate a section of the hole, and through another pipe you pump up the fluid pressure inside that hole until it cracks the rock.
Okay.
Because the fluid is being injected into the rock, it needs space to occupy itself, and the easy way for it to get that space is to crack the rock. And then a crack runs out, typically about 200 feet on either side, and maybe 30 or 50 feet high. So it's a very elongated, elliptically shaped crack. And now the gas can flow into that crack from each side, along the crack, into the borehole, and up be produced.
Right.
But you need to produce many such cracks, as I said, about 20 meters apart, in order to mine out the gas which is present in that seam. And you do that for all of the boreholes that have been drilled.
Okay.
That's the hydraulic fracturing.
Right.
So having cracked the rock with high pressure fluid, it then flows back up the hole. It's called flowback, because you don't want the gas to stay there, because the gas will push it out.
Yeah, yeah.
You don't want the
It
liquid to stay
naturally comes out, does
That's
it?
right. So at the end of the day, you end up with a system, a borehole, many cracks, dry, just gas flowing up out of the borehole.
And as you say, that can last for 10 years.
Yeah.
Yeah, that's
Depending on
amazing.
circumstances.
As I said previously, the propaganda about the whole process is that it's very crude, and that's just couldn't be further from the case.
Well, the other thing is that people have complained about fracking damaging water supplies or polluting water supplies.
Yes.
First of all, in this country, over 90% of drinking water is not produced from underground sources at all. It's produced from surface reservoirs and rivers.
Right.
Only Southern water, Thames water, produce significant amounts of drinking water from underground sources.
Okay.
The aquifers are generally no more than about 100 or 200 metres underground. Shale gas is produced at 2.5–3 kilometres down. It's a long way away.
Okay.
Whenever you drill a hole in the ground for any purpose, you have to drill through water-bearing formations.
Okay.
And you have to seal, not just once, not just twice, but usually 3 or more times, especially for gas production, the borehole against the wall rock.
Okay.
So there's no chance of the gas escaping into the water.
So what you're saying is the process is extraordinarily safe, and it's not true, basically, about waters being poisoned by fracking.
No, quite apart from that, methane gas is not poisonous.
Okay.
It makes it bubbly like champagne.
I bet it doesn't taste as nice as champagne.
Well, I've never drunk methane saturated water, but I suspect it's got no taste.
Oh, really? So it doesn't taste as nice then? No. And a very small space at the top. Very small.
Yes, about 1 hectare, the size of a football pitch.
1 hectare. Well,
Yeah.
I was going to ask you, that was one of my questions actually. In terms of the energy that can be taken from the ground, say for example the Preston New Road site, which is 2 acres, 2 football pitches approximately, with 60 proposed wells, what would be the equivalent size of a renewable area that could generate the same energy it comparatively?
Well, petroleum and petroleum gases are incredibly energy dense.
Right.
You just, to prove that, you get in a car and you drive from here to London, you haven't even got an empty tank.
No, that's true. Yeah, well, I did that yesterday.
But try doing that in your battery car and coming back as well.
Absolutely.
Not
So
so
what
easy.
would be the equivalent approximately? I know you can't tell me exactly, well, you probably could tell me exactly actually, but how many football pitches as opposed to the 2 at the Preston New Road, say for solar, for example?
Offhand, I don't know, but I could work it out, and it would be large.
It would be
You're implying
considerably
it's going
more.
to be large, and it would be enormous.
It would be enormous.
In terms
right.
of energy density, we've got nothing to compare with petroleum gases.
Okay. So, sorry, I interrupted you. I apologise. How long would the drilling process be on average?
So to drill the hole might take 2 or 3 weeks.
Okay. Is that when the seismic activity might happen, or
no.
is that with the water going in?
Only when the water's going in.
Right. Okay.
So you to set up the whole site and to drill the wells, so that from one wellhead we might have 16 wells going down. It would take probably 3 months of that sort of order.
Okay, so we're not talking years.
And then the fracturing operation would take place over a slightly longer period of time, but the whole job in and out might be 8 months when you
8
get the whole
months.
thing swinging.
Right, and then how long could that, as you say, the 1 hectare, how long would that be able to produce, or how long would gas be coming out of the ground, basically?
Well, it depends on a lot of imponderables, but
Right,
we're probably talking at least 10 years.
Right,
It could be
so
longer.
8 months and then activity.
Yeah, it will last a long time.
Okay, all right.
But the circumstances vary from one field to another.
Right. In terms of the, thank you for explaining that to me. So in the US, we've touched on this before, but them having fracking and having had it for well over a decade now, it would have reduced their CO2 emissions considerably, wouldn't it?
So they've been producing shale gas since about 1990 in the US.
Oh right. Oh okay.
A very
So
long
that's
history.
that's a much longer time
And
than I
of course,
thought.
it's had a profound effect on the economics of energy in the United States.
Will they pay? Is it 8 times less for their electricity than we do? Something approximately.
Well, in, for example, Pennsylvania, where most counties permit hydraulic fracturing to go on to produce shale gas, it butts against the border with New York State. If you cross that border, you won't be able to do it.
Really?
So because there's a moratorium in New York State. So
You do surprise me. The wokest place in America, they don't want fracking. That's not a shock at all,
that
is
was
it?
Mayor Cuomo who did that.
Right, okay.
So the prices vary tremendously from one place to another.
I
And there
see.
was a story going around a few years ago that people who lived just on one side of the border wanted the border moved so they could be in Pennsylvania.
So they could get, get cheaper energy.
But of course, in the United States, the energy underground, all of the mineral wealth under anyone's plot of land is owned by them, all the way down to the middle of
That's
the earth.
completely different to us, isn't it?
It's the Crown Estate which owns everything.
Yeah, which is good and bad. I think a lot of people would be extremely pro-fracking. They might even be out on the streets if they could, make a tremendous amount of money from, the gas under their houses. But I've been reading actually that in America, 15 million people live within 1 mile of a fracking site. But what I was thinking is, do you think to allay people's fears here about seismic activity and things like that, whether it would be better for us to start fracking in a more rural area to prove that it was safe?
Well, there's no doubt that if you can do this kind of operation far away from where there are lots of people, then they're not going to object.
Yes, yeah.
I mean,
that's
just
a
a
common
fact.
sense.
And
Yeah.
we've got population density in this country which mitigates against the whole business being very popular with the general public. But I do feel that once they get used to it, then a lot of the problems will disappear. Let's just think back to the whole of the 20th century when we had coal mining, and in particular in the English Midlands, for example, people would get up on a Monday morning, they'd go to work, digging out the coal, they'd be inducing seismicity left, right and centre.
Yeah, they would, wouldn't
And
they?
they'd come home on Friday and the seismicity would stop, and then it would start up again the following week.
Right, okay.
So because of the economic imperative that this is where the jobs are, people accept a bit of low-level seismicity. And we are talking low-level.
a lot of people think that the Earth is completely still, and then if there's any seismic activity at all, you'd be able to feel it. But that's not true, is it?
No,
The Earth is
no.
moving all the time. I mean, would you even feel a 0.5 on the Richter scale?
No chance. You won't
What
feel-
is that an equivalent to?
You won't. Something of that sort of size is a bit like dropping a bag of sugar on the floor.
Okay, so the Earth's
No.
not moving.
I need to explain the concept called the magnitude-frequency relationship when it comes to earthquakes. And this is something that, about the Earth that works really, really well. You find that in any given area of ground, for example, the whole of the United Kingdom, that you may have, say, 10,000 earthquakes a year, and these will be around magnitude 0.1. And then you might have 1,000 magnitude ones, and then as you increase the size of earthquakes, you get smaller and smaller numbers of them. So there's a very, very precise relationship which is observed, because this is the way Mother Nature does things,
She's wonderful,
between
isn't she?
the magnitude of earthquakes and their frequency, how often they occur.
Okay.
So you get a lot of little ones,
Yeah.
you get a smaller number of bigger ones, and you get a very small number of very big ones.
Okay.
But what that means, and this is really useful, is that if you know the slope of this line and where it lies, and you want to assess whether you want to build a really fancy piece of architecture which you'd like to last for 200 years, you extrapolate that line down and look at the frequency of earthquakes and their size over a period of 200 years. And if
Okay.
you find that it's off the graph, you go ahead and you build your piece of architecture.
Yeah.
But if you find that the probability of a damaging earthquake is, for example, once in every 200 years, you think twice. Now, this is not a very, very precise prediction, is it? It's a probabilistic statement.
Yeah.
But it's a very useful guide to the seismic hazard and the potential risk of undertaking something which you want to last for a long period of time.
Right. Okay.
So that's a very useful and very general relationship that works as a basis for predicting the likely size of earthquakes over a given timescale.
So we are constantly experiencing small earthquakes all the time
All the time.
that we have no.
We
don't
no
know
idea.
about. No.
We'll only feel things which are magnitude 2, 2.5 and larger.
So the Ed Davey 0.5 sounds ludicrous when I hear you saying that. It's almost as if you wanted to kill it before it started.
Well, the idea of having things set so low was so that if there was a gradual build-up, even of things which couldn't be felt, but could still be detected just about.
Oh, I see. So you're letting him off the hook a little bit.
You're looking ahead as to what might happen.
Yeah.
But it's still a very crude tool.
Right.
And certainly other countries have adopted more realistic kinds of things, because you're not going to get damage produced by earthquakes less than 3. And remember, it's a logarithmic scale. It's very non-linear. So every step increase is many times increase in the energy release, and magnitude is used as a measure of the amount of energy released in an earthquake. That's not the same thing as how that energy will be realized in particular circumstances. So, for example, if you have soft ground, for example, on a river channel or on a beach, the same seismic waves
It'll be felt differently.
will feel differently.
What, is it because
They'll
it's
be more
absorbed?
damaging in soft sediment than on bedrock.
Really, I would have thought, obviously,
It was a
we're
very
not having a
simple
clue that
experiment.
it's the other way round. But no, oh, okay.
What you do is you take 2 plates,
Yeah.
one with a block of cheese on it,
Okay.
the other one with a jelly on it,
Yeah.
and you take a small insect and you place an insect on one, an insect on the other, and you shake them both together.
Okay.
Which insect will be happier? The one on the cheese, obviously, than the one on the
Yeah,
the
because
jelly,
they've been moving around
because
so
the
much.
jelly will amplify the movements.
It doesn't absorb it. It hasn't got as much structure to cope with it.
It's the elastic modulus which is important.
Right. Well, that's really interesting. Right, okay. I've learned probably the millionth thing that I've learned just then in the last half an hour. That's wonderful. Just we've touched on the anti-fracking thing. We've talked about the information and all the anti-fracking media and protests and stuff like that. Can I just ask you briefly about your experience with the anti-fracking people that came to interview you? If you don't want to talk about it, you don't have to. I just thought it might be interesting for our viewers because it actually put you off the whole concept of being interviewed full stop, didn't it? That's why we're so grateful. Thank you for having us today.
Well, in my experience, going along to a meeting, for example, where I would put the case and the science behind shale gas production, the people who were dead against the whole business were beyond any kind of persuasion.
Okay, so almost religious in its
like a
dogma.
religious fervour.
Yeah.
They weren't interested in listening to science. They weren't interested in physics or chemistry or anything like that.
These are the people that say the science is settled on everything. You don't need to debate it.
And I will always insist that scientists and engineers are just as passionate about trying to remove hazards, environmental hazards, especially those that are caused by people, as any number of protesters.
Yeah.
The difference between these two groups of people is that an engineer or a scientist can do something about it, but an activist can't.
No.
So it's just hot air.
Yeah.
But they make an awful lot of fuss and cause a lot of irritation, which is completely irrational.
Well, it is completely irrational. I mean, what do you think of these groups like Just Stop Oil, who only seem opposed to new oil and gas exploration, bizarrely, and also Extinction Rebellion? I mean, do you think that they're legit? Do you think that they're actually... I mean, a lot of them, Just Stop Oil admitted with me recently, actually, on GB News, that they're funded by Getty oil money. I don't know if it was supposed to slip out, but it did. So it does make you question the integrity of some of these groups. What do you think about them?
I think it would be wonderful if we could just stop oil, just stop gas, and move on to the sunlit uplands of green renewable energy. And it'd be wonderful if we could do that tomorrow, but we can't.
No.
It's just not possible. You can't just switch off a massive infrastructure that supports the lives of so many people overnight.
To a certain level of standard of living that people are very used to.
That's right.
Too.
And it's going to take time. And to make these infrastructural changes is going to require a little bit of help from hydrocarbons.
Okay.
You cannot turn your backs on these things. You have to think about practical ways forwards, not airy-fairy thoughts that don't mean anything. And gas, in particular, as well as being a fuel that we burn, and we have to stop shoving stuff in the waste in the atmosphere, which we can do, it's an engineering problem. As well as that, it's also the chemical feedstock for a huge fraction of the industrial chemical industry. So the manufacture of your automobiles, the plastics in the automobiles, your rubber wellies, a huge range of different sorts of products are made from natural gas.
Oh, right.
We're still going to need that. But what will surprise you is when I tell you that 2.5 billion people cannot survive on this planet without nitrogen-based fertilizers that are manufactured from natural gas.
Yeah.
It's that important.
Yeah. Well, look at what happened in Malaysia when they tried to switch
Look at what's happened in Ukraine.
Yeah,
when there was a sudden hit to the supply of industrial fertilizers. It's so easy to chop it off, and it all depends on gas. So you cannot just turn your back on fossil fuels overnight. There's going to be a transition, and that transition may involve the opening of new explorations. At the present time, we've seen that Europe is
so the opposite
is desperately in need of energy, and some of that can be supplied by new developments in the North Sea, for example.
Yeah.
So when the British government says we'll encourage new developments in the North Sea, it doesn't mean that we're going to get that. It means that the rest of Europe, which we are bound to support, are going to be able to get that. But of course, it's the exploration companies that are going to produce the resource and sell it
Yeah.
It doesn't become the property of the British government.
Well, Sir Keir Starmer said in the last few days that he would be restricting exploration and drilling in the North Sea. I mean, for oil, it's just madness on one side and absolute madness on the other. I mean, talking of madness, I've just written some figures down here. Drax, we touched on this before, is currently importing 27 million trees per year, mainly from America, using natural gas to dry them, shipped across the Atlantic using diesel, then trained to Yorkshire. And when they're burnt, they have higher CO2 emissions than burning coal. And this is the best bit, £2 million public subsidy every day from you and from me. This is crazy. Isn't crazy the only word?
Plus the particulates as well, don't forget them.
Yeah, so the particulate emissions.
Oh yeah, I think it's completely insane.
It is absolutely, completely insane. I think one thing that you and I would probably agree on is that CO2 is a greenhouse gas. Whether CO2 is causing climate change, or to what extent it's causing climate change, is heavily debated, and I don't really necessarily want to get into that now. But I mean, is there an argument though that CO2 can be a good thing? I mean, like global greening, for example. I mean, we have seen substantial greening of the earth in recent years, which a lot of people have attributed to increased CO2 emissions.
Well, CO2 certainly helps plants to grow.
Yeah.
But those plants are going to have to get by in a less friendly climate. So yes, there are pros and cons, but I think that the cons in this particular case probably outweigh.
So you are a strong believer in anthropological climate change, i.e. man-made climate change.
Yes.
It's interesting. Why do you think that, even though you have that belief, which a huge amount of people have that belief, but you still support fracking, when a huge amount of people who share your beliefs on that side of the argument are very anti-fracking and indeed use the climate change, the man-made climate change argument to back up the reason why we shouldn't be fracking? I mean, what can you explain that?
Well, people who object to things like fracking or hydrocarbons in general kind of take the view that every excess cubic centimetre of hydrocarbon is a bad thing and cannot be allowed to happen. What I'm saying is that we need to burn a lot of kilograms of hydrocarbons in order to bring about this change, this desirable longer-term change to a relatively carbon-burning free world. But of course, we still need hydrocarbons because we use them for other industrial
So the whole
processes
just
as
stop
well.
oil argument, it could never work, even in an ideal situation, unless, I mean, of course, we have been powered by renewables before completely in this country, but that was 200 years ago, before the Industrial Revolution, when the life expectancy was 40. I do think sometimes that some of these organisations would quite like to go back to that. I know you and I don't feel like that, but
Last week, the wind was blowing and there was a lot of spare energy produced from wind power. This week it's flat calm out there.
I know, and February's there'll be hardly any wind, and it's going to be freezing, and the sun is at the wrong angle, is my understanding, for the solar panels. So yeah, and the month we need it the most is the month where we don't have any at all.
You have to have the capacity to produce that base load.
Yeah.
And of course, one way around that is to develop methods of storing electricity, and that leads me on to another thing, and that is that one of the things that people in general have to understand, that as time goes on, we're going to have to drill more and more holes in the ground, whether they like it or not.
For gas?
No, not necessarily. Obviously, to produce fuel fluids, that's one thing, but also to store energy, to store hydrogen, to store compressed air, to dispose of carbon dioxide as waste.
Carbon dioxide can be reused in terms of, it has industrial uses though, surely. It doesn't necessarily have to be...
That's right,
yeah.
That's quite right. The amount that we need to get rid of is far in excess of what we'll need to use for industrial purposes. But yes, we do need CO2 as an industrial product. It's used in various kinds of processes, like making beer.
Well, yeah, there's nothing more important than that. Okay, so A colleague of yours and a friend of mine, an advisor to Car 26, Mr. Brian Catt, wanted me to talk to you about hydrogen. I'm a bit nervous about having this conversation, but here I go. So he said that hydrogen is highly volatile, highly combustible, and that actually the element that makes it safe in terms of putting it into people's boilers, etc., is the carbon in within it, which everyone's talking obviously about removing to make it lower emissions. So what would your argument to Mr. Catt be on that?
Well, with a gas boiler, if I can cast people's minds back about 60 years.
Okay.
When we used to have town gas, which was made by the gasification of coal.
Okay.
The destructive distillation of coal. And that produces a gas which is about 50% hydrogen, and most of the rest is carbon monoxide.
Monoxide.
So, monoxide.
That's the baddie, isn't it?
So, and of course it burns to carbon dioxide plus water.
Right, okay.
That is why in the old detective movies and so on, and you could top yourself by sticking your head in a gas oven. You can't do that anymore.
I've often wondered about that. I mean, I haven't considered it, but I've often wondered how they managed to do that. It's from the carbon monoxide.
Is a poison; it will kill you.
Yeah.
Whereas all that methane will do is asphyxiate you. So it'll take a bit longer.
Oh, okay. You have to have your head in the oven for a bit longer.
So we have in the past burned hydrogen in gas boilers.
Sorry.
Now the main difference between the handling of hydrogen then and now is that the hydrogen was produced at low pressure, and it was stored in these enormous gas cylinders called gasometers, and they stored the gas at atmospheric pressure. So it was distributed around in steel pipes at low pressure, and so we were burning hydrogen in gas boilers. The pressure of the gas in the boiler is even lower than atmospheric pressure, so there's no hazard to burning hydrogen gas in a boiler. It's just an engineering question.
Okay.
The only difference between then and now is that now we distribute gas via a network of pipes at high pressure. So most of the gas storage is underground, and it's the pressure of the gas which makes it able to store a large volume when it's expanded. So we don't need gasometers anymore. So in the distribution of hydrogen, we'd be sending it through pipes at higher pressure.
Okay.
We couldn't do that in steel pipes.
Okay.
Because if you pass high pressure hydrogen through a steel pipe, it'll split the pipe.
Right.
And it will do it because it works its way in between the crystals, and it literally unzips it.
Okay.
But we've seen in the UK in recent years a massive programme of conversion of the old steel gas pipes to plastic. Doesn't have this problem.
Right.
So all of that infrastructure work has already been done.
Plastic, which is made using chemicals and oils. Yeah. Thank you for explaining that to me. The other thing that he asked me to put to you, he said that in terms of producing hydrogen, that the amount of energy that is required to actually separate it from to separate it from the gas as a whole, it is actually more than or equivalent to the energy that you produce afterwards. So therefore you actually, it's almost pointless.
I don't subscribe to that view.
Okay, I knew you were going to say that. Okay, why not?
And there are two main ways of producing hydrogen for industrial use. One is so-called green hydrogen, which is produced by electrolysis of water. So the idea is you would make you would use the cheap nighttime electricity when the wind is blowing from solar plants, and you'd hydrolyze, use that energy to hydrolyze water, and then that separates the hydrogen and oxygen, and you pump the hydrogen down underground, store it underground, or in bottles, or depending on what you want to do. Oxygen you can use for other things, like in hospitals, and you get out what you put in. So many joules of electrical energy will produce the same number of joules of chemical energy when it is recovered from hydrolysis.
So what you're saying is it would be worth doing?
What you put in is what you get out. That's bioelectrolysis, which is the best way of producing hydrogen, but it requires excess electricity to be able to do it.
Okay, so it wouldn't work in February then? If
Well,
we were
not
reliant
this
on
February,
renewables,
but,
for example.
but provided the wind blows, and there are other kinds of ways of getting the electricity as well, like hydroelectric power.
Okay.
And you can also store that energy, of course, by using the electricity to pump water from a low level to a high level, like we have in the Denowick power station, or you could use so-called gravity batteries, where you move a big weight, like a pendulum weight on a grandfather clock, up and down an old mine shaft. There are lots of possibilities for storing energy, but hydrogen stored underground in old gas reservoirs, depleted gas reservoir, one, compressed air. Use the energy to compress air. That's storing energy, and you can put that underground, because at 3 kilometres depth, the weight of the rocks above will keep stuff bottled in. So they're ways of storing energy, but also you can produce hydrogen as so-called blue hydrogen, which is by the steam reforming of methane. That's natural gas. So the feedstock there is natural gas, and you react that at high temperature, and it produces hydrogen and CO2, which has to be separated off, and it's easy to separate those off and buried. And then the hydrogen can be piped straight into the gas distribution network, or it can be buried.
Right.
But the key thing, especially with the CO2 created in that reaction, is it is produced at a high pressure. And if you think about compressing gas, and you know this when you pump up a bicycle tyre, it costs mechanical effort.
Yes, yes.
And so a very substantial part of the work involved in compressing gas is just involved in producing usable hydrogen gas. It's just compressing, or in taking carbon dioxide and pushing it underground. It has to be compressed first. Whereas if the reaction produces the gas at high pressure, a lot of that work's been done already.
Of course, all of this is only even thought about or considered to be necessary if indeed someone has the belief that CO2 is causing problems with the climate. Because otherwise, if it wasn't causing problems with the climate, I'm not saying it is or it isn't, there would be no need for any of this, would there? Because we would just be using natural gas and just carrying on as we are.
Well, I don't accept that point.
No, I know you don't, and I respect that completely. But without that scientific premise, there is no need for the other things, is there? For example, Brian Catt, I know I keep going back to him. He doesn't believe that CO2 is causing any problems in the climate at all. So his argument would be that what you're describing, whilst it's extraordinary and brilliant scientifically, it's unnecessary, and he would also argue, I'm using him a lot here, so I don't have to say that I'm saying it. He would also argue it's extremely heavily subsidised for not very much point whatsoever. But then, if you believe that CO2 is causing problems in the climate, then obviously it would be worthwhile doing. So, okay. One more thing to put to you, and then I've got 5 quick fire questions. Thank you so much, by the way. It's been really fascinating talking to you. If CO2 is the enemy that some say it is, why on earth are we dealing with, trading with countries like China, India and Russia? I mean, why aren't we sanctioning them? And why on earth are we buying solar panels and wind turbines and things from them? I mean, they're the biggest producers of CO2 on the planet. What are we just exporting our CO2 emissions over there and deindustrializing ourselves on purpose? What do you think about that?
I think it's a question of economics, because you can buy these desirable products from countries which exploit people.
Yeah, and minerals.
For less than you'd have to do in this country.
No energy security though, no national security. You talked about that being a priority for you.
The production of rare earth elements ideally should be done in this country.
In 90% China. Rare
Absolutely.
earth.
And you should look on a satellite image of what the mines look like. Disgusting.
Really?
They're really brightly coloured areas of pollution.
So, you know, when you've got countries that are not taking any notice of all the things that we've been discussing, CO2 emissions, it does make you think, what on earth is going on? Why would we still be dealing with these countries if indeed there is a strong belief?
We don't have to pay as much.
Because literally just an economic argument.
Yeah.
And we're willing to sacrifice our security completely for that.
Well, we certainly had been.
Okay.
I think the Ukraine situation has been a wake-up call in that respect.
Okay.
And
of course, energy prices were increasing extraordinarily before then, weren't they?
And I think that we need to look a bit more close to home for quite a number of other industrial products in the future.
Okay, I totally agree with you. Right, we're coming to the end of our lovely discussion. 5 quick-fire questions for you. First one, climate catastrophe or no climate catastrophe?
Well, I've observed the way things have been changing. I remember going into high mountainous regions when I was in my 20s and seeing all of those glaciers. I've seen how they've retreated, and I have been shocked in such a short time frame. So I've certainly developed a prejudice as a result of that experience. But quite apart from that, the rate of change of climate is faster than we, and I know that Brian Catt will disagree with this, is faster than has been recorded in the geological record throughout the tertiary period.
Okay, obviously, you know, that's your interpretation, and there are others that disagree with you, but I obviously completely respect what you're saying. So your answer would be climate catastrophe then?
Yes.
Okay. 2, fracking or no fracking?
Well, I think that if it is at all possible, we should have a shale gas industry in the UK.
Fantastic. Fracking or wind farms?
It's not a choice.
Right, both.
Both.
Okay. 4.
With all of energy supplies, one thing is not the answer.
Okay, diversity.
8 or 10 things are the answer, used in the appropriate proportions for different reasons.
So both. Juicy steak or a salad?
Well, I don't particularly like steak.
Okay, meat in general then. Just, I suppose what I'm trying to say there is there's a massive push for us all to not eat meat.
I think that is a relatively minor effect.
Oh right, oh okay. So you don't think that the production, dairy, meat farming is causing particular problems with the climate?
And there are also ways around this as well.
Oh, that's very interesting. Thank you for telling me that. 5, heat or eat?
You have to have both. You have to have both.
Have to have both. That's brilliant. Thank you very, very much, Dr. Ernest Rutter. Really, really enjoyed our talk. Thank you very much. Thank you.